My task has been little alleviated, made easier by Dr. Sundaresh Pilla's presentation. The issue of climate change, and he said about the climate variability. These are two things. It is not interchangeable. They are two different things, but one can, especially the climate variability, can influence on the climate change pattern right now going on. And as a geologist, when you look back to the geological history, there were five species extinctions in the geological period spanning over 200 million years past. Ago. That was all. Like the dinosaur extinction. These are all climate variability. That has happened due to the processes that is imbibed in the process of the transition and evolution of the Earth. When it comes to climate change, it is basically attributed to the human effort now, and the thought about it started way back in the 50s. Then, when there was only one carbon dioxide monitoring station in the whole of the world, that was in Mauna Loa in Hawaii, because Hawaii is the center of volcanic eruptions. In the 56-57 period, they were looking at the whole carbon. There was a trend. They saw some difference in the trend, something more coming. 56 to 59 period, that was a sort of conjecture. That sorry, I'm not taking for a ride every one of you, but at the same time, these are some of the interesting facts. That time, one of the scientists who was working on who was in that station, he was very closely connected to Patrice Moynihan. Moynihan was the ambassador of US to India. So when this matter was put across to Moynihan, Moynihan was a politically connected person in America. He shot a letter to President Nixon that time. This is something very interesting, something happening, that the carbon emissions are going up and this is unrelated to the natural processes. We have to do something. But that time Nixon was in trouble, political trouble, Watergate. But he did one thing. In 71, these things happened in 68-69 period. In 71, he brought the American EPA, Environmental Protection Agency, and the bill, various protection, environmental concerns, and the robust system of environmental monitoring and mitigation measures in the US was initiated by, then the Republicans take credit of always, because I met some people, they always, for the Democrats, take care of the nation, things like that. So from Mauna Loa onwards, when you coming, now there is a wide network of carbon monitoring systems in the whole of the world, and they get it. They are now, the rest is all history. We know about what is happening. So that is about that. But then there is a nuance of what happened in, say, for example, Krakatoa right now, and at Krakatoa, that is a variability factor contribution. But now it is possible to differentiate between the two because the network is totally available, globally available. So with this little words on the introduction part, I get into this one. Basically, when we're talking or we're thinking about these things, though the first manifestation of a major change in the climate was recorded in 82, after what you call the century's most severe El Nino phenomenon in the Pacific. It came to India. The thought of India, whether there is a climate change or whether monsoon is being affected globally. Even when Sarwarkar, who was a top scientist, who was with the ISRO, he was a secretary to Rajiv Gandhi. Those days, he didn't accept that there is something. They always said El Nino will not affect India and something like that. That was our perception of the global phenomena, about the Indian perception. Now it has changed. After 2008-9, I think we started thinking on those lines. So we had Oki cyclone. Generally, Arabian Sea is not cyclogenetic, basically. Now we have seen a couple of them over here. Then the unprecedented floods and landslides of this August. Then we should have a thought in perspective. Okay, if these things are there to stay, and then how do we go about? Whether we will have Dr. Pillai was telling, whether we'll adapt to the whole thing, or we'll be resilient, or we have to make some adjustments, whatever maybe. This is all open to the what you call those who are in the realm of administration, and those who are on the receiving end. So therefore, I start with the resource. In economics, basically, the economists rule the nations, and you know that. And a resource is defined as a commodity, service, or other asset that produce goods and services that meet the needs and wants of people. Needs and wants. Gandhiji said about a need. Now our generation speak about the wants. I want it. We don't know whether it is available there. And in natural resources, it is very simple, a resource in the nature. It is again any material substance or organism found in nature that is useful to people. Some are necessary for life. So, for example, water is necessary for life, air is necessary for life. This we know, two things. And there are others which are they add to the wealth of the nations. That those parts cater to the wants of the people, like the metals. You have got the oil, you have got metal, gold, or platinum, or whatever may be. Then these are there: light, air, water, soil, flora and fauna, minerals, fossil fuels, all among them. The fisheries, everything is that we have got the resource. Then, when we talk about the natural resources, we have to bring in a word like environment, because we are taking it out all from the environment. Then what's the environment? Because nowadays this word has been totally taken away by the what you call the globalized segment of the economy. I don't want to use a bad name like capitalist or anything. Now everybody is those who own some capital is a capitalist, because exploited is not in the world way, it is something in the different way. But then, what is this environment? Then we have to at least get on to another term, ecosystem. That is also in the business parlance nowadays. What is an ecosystem? It's a communion of organisms. It can be animals, it can be plants, it can be humans, a communion of living organisms in contact or within an abiotic environment. What is an abiotic environment? Water, air, sunrise, mineral soil, these are all the abiotic environment. That means a union of biotic group living within an abiotic system, but linked through biogeochemical cycles, elemental cycles, and energy flows, still acting as a system, and that is called an ecosystem. Examples are humans. We are living, but we require the air, we require water, we require the soil, so we are using them. Then what is the linkage? We don't know. That is the biogeochemical cycles. It is there in the system, not within us. Within that abiotic environment, it is there, and energy flow. That is entropy. So this is an ecosystem. So then what is environment? These enabling factors like air, water, biogeochemical cycles, energy flow, all the enabling factors, you call it environment. How do you define it? These things are reflected in science when you look at either physically or chemically or by energy. So physico-chemical attributes of a habitat with entropy. What is the energy flow? This is what is an environment. So when we talk about environment, emphasize on it is that there is a living, so-called non-living, but they are the facilitators of like air, water, energy, and those things are it. Then there is an elemental cycle. This is a rhythm, total rhythm being there, and we are there. We means humans, aquatic ecosystem, forest ecosystem, desert ecosystem, and number of ecosystems. So without getting into a concept of ecosystem and environment, we cannot come to a resource, and we cannot come to their utilization business. Because why? We start touching one, the other one is affected. This is what the linkage, what I said, the organic linkage of ecosystem, environment, that means energy flow, biochemical cycles, living organisms, and the so-called abiotic thing, biotic, abiotic, but they are all linked. You touch here, you don't know what is happening here, but there is a reflection. This is what we are facing now. So therefore I come to, because we are on the earth, and when you talk about earth, there is only one thing interesting. You look at this one, this is a solar system, this is a sun, this is a planet Earth, third from the sun. And why it is, we seek about life. Why? Here it is an environment, the ambient temperature is such that the one of the most life enabling factor, what is in the liquid state, then there is you have got an atmosphere, the size of the earth is such that the gravity permits to have an atmosphere, and also it thoughts, elements, objects coming to this one, so it is conducive. You come to this one, Venus, it is a hot chamber. is a frozen. So it's something like that. The creation of Earth, who I don't know who did it, the universal evolution creation, that itself is life is only known to exist in this planet, and we have to sustain it. That was a point what I want to say about this when slide putting. And the Earth is being divided into three. I mean, the geosphere, biosphere, and geosphere consists of atmosphere, hydrosphere, and lithosphere. And you know that. Then there was a biosphere. Through an evolution history, transition history spanning over 3 billion years, that means 300 crores of years plus. I mean, though the age of Earth is 4.5 billion, the evolution that started in a big way, and the geologists perceive it as all these things started from something 300 crores, that is 3 billion, to the present day, that is what is happening. And some sort of a rhythm, some sort of a semblance of a equilibrium, and again that equilibrium is a dynamic equilibrium. Like it is not very simple, it will never be static. That was attained something at the end of the Ice Age, ending with the Paleolithic Age, that is 12,500 years before present. That is a time when the people started getting into the agriculture, leaving the stone to the metallic tools, getting into agriculture, the civilizations beginning, and so on and so forth. And then there was a biosphere. I mean, that is again starting, the best thing is 250 crores of years, but the lush vegetation on the surface of the earth, that terrestrial vegetation started something like 200 million years before. Then there were 5 periods of extinction and all other things. And the owners of the land, so-called the masters of the land, the human, the Homo sapiens, all the what you call the original apes of from whom the Homo sapiens evolved finally, their origin was hardly 4 million years before, a small speck of geological time. And the Homo sapiens, as such, our precursors, they were as old as only 0.4 million, that is 4 lakh years, in the Goldovai gorge in Tanzania, East Africa. And they started migrating from there something like 65,000 years ago, and they came to Beijing, they came to Sinai, 2 routes they followed, through Sinai route, going to Europe, then to eastern part, then through Altai to the Chinese part, Beijing. Earlier there was a thought that they were different species being everywhere, because the black is black, white is white, yellow is yellow. No, genome proves that it is all the same. This is from the Olduvai gorge in Tanzania that we are there. Our ancestors are only this one, and that is a sociosphere that evolved. Then you know the history of the human race, starting from the hunting, then grazing, agriculture, and now we are here with all the things. People started intervening, taking out the material from the earth, that the resources, and that was in the Sumerian culture. Civilization, it was in Indus, and it was everywhere. And then we know after some time, all these civilizations perished. What they did? They were living on the banks of river sources. They extracted the fine soil of the fertile land to make bricks, cut the trees for firing it, then water was pumped and used for everything. So they were using only simply 2-3 natural resources, soils they were using, water they were using, and firewood, that means the forest they were using. But we don't know the reasons. These all perished. We survive as a human race right now, the industrial, especially after the post-industrial revolution time, because out of technology we are proceeding, and now whatever we do, we have been doing, that is all on the perils of humans. So then we started acting. What are the drivers of natural resource depletion? It's mining, fishing, agriculture, and so on and so forth. Deforestation, that is also there. Then when we get into one of the major sources of income, wealth to the nations is mining industry. So this is how the picture from 84 to 2016, the world mining, how it goes up. In 84, it was about 9 billion tons, and by 2015-14, it was close to 17 billion tons. Then there was a small decline after the 16-17, because after the Paris conference, there was a small reduction in the production of coal. Small, not big. After Trump, they again went up. Okay, that is in that period. These are different types. This yellow is mineral fuels, that is coal, natural gas, oil, and all the fuel. I mean mineral fuels. The rest is the red is iron ore and etc. And industrial minerals. Industrial minerals by we mean is all for the materials we use for pottery, ceramics, and other things. Those are the industrial minerals we use. Then precious metals, they are small, and the rest is visible. This I put it by continent and nations. By continents and this one. You look at the maximum extraction of minerals take place in the fast emerging economies in Asia. This is why the yellow, that is the major driver in Asia is naturally China. India is a driver now after the 1992 globalization. Indonesia is a driver, then Malaysia, and they extract, then Papua New Guinea, they are little off Oceania. And this is a source, and the red one is Europe. They are steady because Europe has already exploited the whole of the world. They need only to reprocessing some import. They don't require much of it. It's mostly was the case with the US, but now they are changing gears and they are started exploiting the coal, which is one of the most polluting things because they want the rust belt to be activated, and therefore that is going. Then you come to the Africa, that color. It's very little because Dr. Pillai was also telling, these are the, neglected regions of the world. These are the only things they have that is going on. By nations, largest producer in the whole of the world as of now is China with this much. In 2010, the Chinese contribution or the mineral contribution to China's economy was close to $1 trillion. That was 1/6 of China's GDP that year. India's right now is something like 184, something like US stands second, and this is the order that goes. This is for a just comparison. We should also know what exactly for the mineral exploitation is one of the major contributors to economy. At the same time, that is one of the major contributors to the environmental, the global change. We will come to a term before coming to the climate change. There is another term we want to use it here. Then it's also look at how Kerala fares. Kerala's there are major and minor minerals. Minor minerals are something which are values. The value is low, like the building stone, like the ordinary sand, and these things. Royalty is less, and therefore they are called the minor minerals. And major minerals are China clay, bauxite, ilmenite, etc. Their amount for the year 2015-16 is given. Like China clay, for example, close to 6 lakh tons. Then bauxite laterite, there is a confusion because it's a taken out material. I don't know what exactly they mean. Close to it is 1.7 million tons, and this is one thing. Then in the minor minerals, building stone, it is close to 30 million tons. It's official figure. Official figure is 30 million tons. Unofficial and virtual will be 2 times or 3 times. And it is also applicable for the major mineral data being produced. When we said about it is 17.5 billion tons, it can be anything like 30 or something plus. Because there is another computation I will also bring in. Then we look at laterite. There is a 1.4 million tons over major, it was shown. It is 6.7 lakhs tons shown here. Then ordinary soil is 55 lakhs tons. Then there is a confusion. For me also there is a confusion. What is an ordinary soil? There is an ordinary sand. There are a lot of things because it is from the administration report I have taken. But let us go by not by the classification of the minerals they are giving. We go by the quantity.
Just
and what?
The first one is only for Kerala, is it?
It's only for Kerala. It's a Kerala data. This one and the previous one only for Kerala. Because I thought there must be. It will be otherwise. We talk about.
It will be phenomenal all India.
We are nowhere. And also, it will also speak about one thing. The total revenue in the year 15-16 what it received is 140 crores. 140 crores. Whereas the Indian business was by the time 182 billion dollars. That means 182 into 7,500 you multiply, that is the,
You're nowhere.
we are nowhere. And then we look at, from the Mahindra Mirrors, the revenue was close to 13 crores, so 13 crores. And for that 13 crores, 3 crores of tons of granite stone, the actual will be 3 times or something like that, because there is no comparison or no correlation between the number of quarries and licenses. It's all confusion, and what people do, there is no control by the control in the sense by the society. Then ordinary soil. So for us it is soil, but soil has got some other functions. So for that is the revenue. This part is only 13 crores. The major minerals, that is ilmenite, ruthenite, etc., which is being mined in Chavara, Kollam district, that fetches the rest 127 crores of revenue to the state. And for state also it is just like, it's not a revenue. So I want to make this one. The mineral extraction, as I said, is totally 16-17 billion tons as per the statistics of the International Mining Congress, Vienna. But then there is a European calculation on this one. In the developed world, an average citizen consumes about 20 tons per year, person. That is and taking a total population of something like 1,500 million, that comprises the Europe, North America, Japan, China, and part of China, not every China, part of India, because we have got an affluent section which lives at par or better than the Europeans, and no way inferior. If you take it, the total extraction should come to 30 billion tons. That is why I said, the actual mining data need not tally with the real. I don't know, maybe leave it, whether it is 15 tons or 13 tons. Then gravel and the construction material, gravel and sand extraction, the total global production of cement is 4 billion tons. Cement is mixed in a proportion of 5 or 6, sand or whatever maybe. That is the proportion people mix in. One unit of cement and 5 or 6 units of. When you look at it, it comes to 25-30 billion tons of extraction of the material. That is rubble, sand, and other sort of materials you extract for the construction industry. So in India, for example, the cement production in 16 was 324. So multiply by 6, about 2 billion tons, we take it. But then there are other lot of materials being taken for this sort of tiles and other thin decoration stones and these ones. That is also adding to a few billion tons of material extraction everywhere globally, especially in this one. And this is what the humans are doing. And then, because there is an equilibrium question, what is the globe as a unit, the world as a unit, planet Earth as a unit? There is some material from the interior of the Earth, that is from the mantle, coming to the surface of the Earth. This is being found in the what you call the mid-oceanic ridges. There are mountain chains within the ocean, in all the oceans. That is a material coming from the mantle. That is computed something like 5 to 6 billion tons of material is the annual incoming onto the surface of the Earth. So if to maintain an equilibrium between the incoming and that will go back, there must be that much sort of matching. But then you look at every year, because of the lot of change in the land use, landscape alterations, etc., discharge in sediments into the seas is about 50 billion tons annual. That is the global computations. And this is minus what is being stored in the innumerable 18,000 or plus dams built on the surface of the earth. There is a lot of stock over here. Then these are the material we are taking. Globe, when you look at it's a unit, it should have its own equilibrium. This equilibrium we have broken. That is why I use the word the ecosystem. There is a unity, living, non-living, and things like that. There is everything in an equilibrium. You test one, the other will be impacted. We fail to understand that. That sort of impact, this sort of change, what you call on the material flux. That means material flux that is coming from within, and that is we are giving back or taking out changing the equilibrium on various parts of the globe is to the tune of something like 50, 60 or 70 billion tons of material. 1 billion is 100 crores. And that makes the material flux change. The globe is changed. The equilibrium is changed. The global change. And global change drives the rest of the things. Then what happens? Because we have that much of material being taken out as minerals. What do you do with the minerals? We take it out on the surface. After the invention of the combustion engine, our energy sources or driving the machines, what we do? We combust. What happens? Oh, carbon dioxide is emitted. In the process, what happens during the combustion? What happens? We consume oxygen, and CO2 is emitted because C plus O2, CO2. In the original composition of the earth, when you look at in the primeval times, it was composed of mostly carbon dioxide and nitrogen. Oxygen was less. Through a process of transition and evolution that lasted over something like 3 billion years, this sort of an atmosphere we have, where about 78% is nitrogen and 21% is oxygen. Because once the life forms came first in the ocean that started the photosynthetic activity, oxygen release, then there was sufficient oxygen, and when you had the ozone layer only, the terrestrial life started. Because the life could be safe on the surface of the earth, because ultraviolet harmful radiations won't touch, because that happened sometime by Silurian, that is 200 million years or something. This is what the geological perceptions about the things. There is no measurement right there. There is an equilibrium, there was an abiotic, you touched one. And we don't know what happened. We never thought nothing will happen, because in a huge level, magnitude, we are doing these things. Then that was on the lithosphere, hard part of the earth we are doing, hard part of the earth. Then there is hydrosphere. I said already that lithosphere, hydrosphere and atmosphere, 3 constituent units. Biosphere is the one that is evolved over the processes, and then you have the sociosphere. Then in the hydrosphere, what happens? We know that the origin of life was in water. Water is therefore important. Then 71% of the surface of the earth is covered by water, fresh water for terrestrial organisms, etc. That is being provided by the hydrologic cycle. We are talking about the desalination plants. Is a nature's desalination plant, the hydrologic cycle. The heated water from the oceans and etc. that is condensed and comes to the surface and does all the processes, all the life supporting things on the land. Then the water finally sculpturing the earth, making its own producers, keeping some water for the humans and animals to drink as groundwater even, and supporting all the biodiversity. Then it gradually goes into the sea with its sediments. This is a process. That process, then we cannot touch it, I don't say. We can touch it, only we should be careful about the anatomy and physiology of the earth system. So this is, when we look at the global water budget, you see this is the total thing, and oceans constitute 67.2, out of the total water cycle, 97.2% is the seawater, and easily accessible water for the humans. Elsewhere is only the rivers, that is the one. It is 0.00009. It's hardly, you see, this is the percentage, a small fraction. A minuscule of the fraction of the water is contained in the rivers, and the river water's residence time is hardly 1 year. And in Kerala, it will be less because you got a topography which is just like, say, 2,500 to zero level in a distance of maximum 124 kilometers. You can imagine what the gradient is. Somewhere the distance is less. And then naturally there is some water, like in Baikal, it's a huge lake, 0.59%. Then groundwater up to a level of say 4 kilometers, like the Indo-Gangetic plains where the cold belts are there, or in the Saharan beach, etc. That is also, but these are inaccessible waters. The accessible water is only the riverine source, that is very minuscule proportion of the whole water. Then we have what happens, as I said, the civilization, we got into the sociosphere dominating. We want power generation, we want water storage in the dams for agriculture, industry and municipalities. Then we wanted it for flood control. And again, we used as a recreational source between 1951 and 82. Dams were constructed at the rate of 900 per year. We were there, then China overtook. Whatever may be the globally it is happening, we are the major dealers of this one. Then what happens to those? Dams are really good, no doubt about it. Then it affects the cycle and habitat of aquatic organisms. eutrophication and anoxia, in this course where the stagnant water bodies prevail, irretrievable, then it what you call the supports evapotranspiration. You have got a huge reservoir created in some place, and there is no canopy. There cannot be canopy over that. So, and evapotranspiration rates, you accelerate, you have got a huge loss. Then sediments are trapped there. It doesn't take out the sediments. Why do you want sediments, you will ask? This sediment is being brought down by the river. On its course, it is settled somewhere as sand. What is a sand? It is an aquifer layer holder of water or groundwater. Then there is a clays. We require for some other purpose, both for agriculture as well as for brick making or whatever. Then the rest of the sediments go to the coast. And the sea is always on a motion. And if these sediments and water go, the motion, they make a rock and roll, and there is a coastal stability. Coastal erosion is little held back. Then these same sediments contain the nutrients needed for the coast. It is nitrogen, phosphor, carbon, nitrogen, phosphor, like the macronutrients or silica. That's not a macro, but a micro. These are being held back. Then what happens if the water is not reaching in the proper quantity? The hydrologic functions requirement that the water should go back, there is an equilibrium that is lost. Then salinity, at least on the debouching point, salinity will be more. Or in areas like, for example, the Caspian Sea, you know the history of the Dead Sea, because when the waters from the Jordanian mountains, that is from the Syrian Jordanian mountains, were stopped, it became Dead Sea because salinity went up. So fresh water is a requirement even for the saline water. So then groundwater depletion, what happens? The net result, hydrologic cycle is affected. It has to become erratic. So what happens in the material flux, what happened? Global change, total flux scenario changed. Now you started interacting with the water cycle, you have got the hydrologic cycle affected. What is the manifestation of hydrologic cycle? You get it in the form of rain, you get it in the form of climate. If Keralites are talking, it is about the monsoon we are talking about. Okay? And when about the water stress globally, what is the Bloomberg and the UN agencies? So they say in 2001 we were having something like 1800 meter cube of water in the sense that is coming in the form of either rain or snow in the the Himalayan ranges. By 2050 we are going to have almost 100, that means 700 is out. It's one third, more than 35-40% is lost. And the population between 2001 and 2050, there is a difference of something like 30, 40 or 50 crores. It is something like that. At least 30, 40. So water stress is going to be a reality. When you talk about meter cube, etc., this water is the coming water. This is not the water being held on the land or available as groundwater or anything. You see, it comes and part of naturally, it goes like from the glaciers, it melts and goes with the Indo-Gangetic or all the Himalayan rivers. In the monsoons, all the rivers to the sea. So water is going to be a big problem. India is one of the most water stressed region. We will be more water stressed than China because China has access to the Tibetan waterhead. All the Tibetan waters are with the Chinese. So that is their asset. So then this is something we did a study in the Kannada Basin. Kannada Basin, the dam was imported in 1986. Between 18 and 86, 87, 95, we were looking at the discharge. So we had the maximum discharge coming January before the impoundment. It was in June, July. It is with the culmination of the southwest monsoon. That's a normal thing to happen. But after impoundment, what happened? The discharge started peaking in November. That is after or during the northeast monsoon. What significance it has? When you look at the fisheries, the coastal productivity period in Kerala, all the blooming time, the sprouting time, this is the June, July. That is the fishermen know that, fishermen knows and the marine scientists know about it. So this is a time when you talk about the fresh water for changing the salinity pattern and making the EH and pH business together, as well as the nutrients coming. This was the time the coast wanted it. But we are able to give it only this time. It is just like I wanted oxygen at a time, but after 3 months I get the oxygen. Will I survive? So Kerala's coastal productivity on one side, and also what is happening in the Ashtamudi estuary. This river is debouching into the Ashtamudi estuary, and there is a productivity loss, and also there is a major issue of one island in that estuary under subsidence, whether it is due to real geological subsidence, or due to sea level rise, or due to non-availability of sediments. This is not known to us. Because why I say is that within the dam upstream of this river, 47 million tons of silt has been accumulated. That is the result being given by the KERI, Kerala Engineering Research Institute. Whether that is responsible for this phenomenon there, or it is sea level rise, or it is subsidence, is a scientific question. That means the problem of Andro Island, because that is an ecological issue, like the unprecedented floods and landslide, call it what you call the disaster of the century by the United Nations. The same way is the Mandro Island in Kollam district. Its subsidence is a climate impact or something. But from these three angles you have to investigate, then only you find out what exactly is the reason. Now, water, I left it, it's all broadly. On the air, what happens, as I said, 78% of nitrogen and 21% of oxygen and some trace gases. That is after the evolution milieu was completed. That was a time maybe when the humans, 12,500 years before we started into the agriculture or whatever may be the business, that was a time, sort of an equilibrium time. This was the quality of the air. Now what is happening? We have started taking out all the material from the interiors of the earth, the minerals, oil, gas, coal. We started producing products. Then what happens? We are using water, you are using air, then chemicals we are using. In the process, what happens? Effluents come. Effluents, what we do? We discharge into the land or water body. All the emissions go into the atmosphere. So we are changing it. And the availability of oxygen, which is very, very necessary, essential. Because when we talk here, without water we can stand for some hours, but without air we cannot stand for a few minutes even. So a day may come, like in our childhood or 20 years before, we never carried a bottle of water when we were traveling. We never carried, but now we are carrying. A day will come when you have to carry this one if you are polluting the air the way that we are doing. So in the air also we are doing the same thing. And also this is one thing, cosmonauts have said that the veils of dust 500 meters and more thick hovering over large cities, they were recording, the cosmonauts. Then emission polluted, then you have got the greenhouse gas effect and climate change. So lithosphere we started interfering with the lithosphere. We have the product. We started with the hydrosphere. We have got the product including the hydrology cycle and salinity rate, coastal productivity, and number of things. This is only not one. And sea level, whatever is happening, sea level rise or everything. And then with the atmosphere you have started, this is the one effect that is coming. Then soils. So what is soil? This is something like a biochemical lab, which is we don't know. Below the soil, what is the millions and millions of biota? We are unmindful of that. Then farming, mining, all these things, what is we compact the land. When we compact the land, what happens? We compact it mechanically, and in agriculture we use chemicals, fertilizers, all these microorganisms we are obliterating. I don't say we should not do it, like the Americans do. They tend to make people to keep their fields fallow for some time, so that there is a regeneration. We don't, because we cannot afford that, because we have less land and more population and we have to have it. Okay, then we do it. A lot of impacts. Then this is something like what they call the SCOPE Policy Brief 2007 SCOPE. That is Scientific Committee on Problems of the Environment. That is a UNESCO affiliated body. What they say, this is about the biodiversity below surface. That is millions of that one, the biochemical lab that creates the fertility of the soil and what life-saving systems, how do they work it, and then we know that that soil is below the earth, below the ocean, and below the rivers and water bodies. It's a continuum. Without that, there is no process going on. Therefore, these are three segments are given. How do we go it? It affects food production, carbon sequestration, water quality and quantity, hobby, and whatever is happening on the land and soils, and fresh water below, what the soil there it is doing, and on the system. So these things are happening because of our intervention, and in the reverse is that they accelerate the global change. That is on the soils what we make. Then impacts of agriculture. What happens? This is again the policy brief from SCOPE, Scientific Committee 2009. That is because it's a body, this is a UNESCO affiliated body, a voluntary agency going on generating this sort of information through international top science interactions and as policy briefs to all governments. But there is nobody like to listen. What are the effects? It land degradation, then it is all shown in 2000 million, 30% of the world's cropland is affected, depletion of water resources, then so much of annual loss is kilometer cube of water, depletion of soil nutrients, nitrogen, phosphorus, potassium deficiencies, percentage is given, then salinization of the irrigated lands, 34 million hectares per annum, then loss of biodiversity and agroecological functions given in $1,542 billion annually, that is because of the farming. Then increasing water pollution, that is reduced quality, 1.5 billion being affected. Then it is what we call a promoter or catalyst of climate change. Agriculture corresponds to 50% of the greenhouse gases. 85% is industry and other human activities. So then we have got the forest, the nature, what you call the forest by biodiversity. It is aesthetic and curative functions. Curative why? It is something like the beauty, the aesthetics of the land. 85% of the medicinal ingredients in modern times that come from biodiversity, the animals and plants. So especially for a aging sick population of the present times, that is a big resource. Then it has got a climate function, climate regulatory function. You know that photosynthesis, even that process was even known by the 60s. Calvin Mervyn got the Nobel only in 60s. So we didn't know before that. This is something like the trees, the forests. They sequestrate carbon dioxide and release oxygen. Then neutralizing noxious chemicals. It filters water. It holds water. A full-grown tree, for example, is said to hold 6,000 liters of water. Imagine in a flood scenario, thousands and thousands of trees in the upper catchment, they will be also holding the soil with their root systems and also holding 6,000 each. How much water it will hold? It will be holding, first thing. Second thing, then it is not a very miser sort of thing. In a lean season, it adapts, it releases. That used to be the source of perennial flows in rivers. We don't have perennial flows because we don't have forest cover. Then, soil nourishment. Without biota, there is no soil nourishment. It has got a recreational value besides timber. And today, in all, especially in our places, it is all timber economy. They look at the value of forest only based on the value of the timber they are selling, not on the forest functions, which are more valuable, more valuable. Then climate change repellent, it is one thing. Everybody says. Forest destruction, when we look at forest worldwide, it is loss of about 16 million hectares per annum. It is a statistics of 90. Everybody agrees that there is no reliable statistics on the forest decrease. Afforestation is 3 million hectares per year. The net loss is something like 13 million hectares. Forest left is less than 30%. It is like the Kerala figure. You ask the forest department, they say 28, 29 is their percentage. Then Chattopadhyay has got a work in 80s. It is only 14%, which is substantiated later. Now it will be 7 or 8 or whatever may be the natural forest, not the canopy. Then last 10,000, 12,000 years, the rest has been, we have done away with an indicator of global change. It is affecting lithosphere, hydrosphere and atmosphere. All the functions of the forest helped. For example, why? Soil creation, soil nutrition, it helps. Climate regulation, it helps. Then water holding, it helps. So forest has got a big value, bigger value than what we perceive as of now. Now the question is, what do we do? This is after we do the whole thing. Like now I come back to Dr. Sudaresh Pilla. Adapt or not to adapt? I thought about it, how to conclude it. We had a big thinker, who died recently, Stephen Hawking. What you call he's regarded as the thinker of the century. He said in an interview to The Guardian in 2007 that the humans will have to find another planet, an exo, whatever may be, exo or endo, we don't know, a planet, because life will be very difficult over here. All the projections by biologists, those who are dealing with the flora, they say the forests and these things will be lost in, there are various one, anything between 170 years to 250 years, the total thing will be obliterated. There are, that's our findings coming, projections coming. That is one thing. And then, in the beginning of the last century, there was a very bright scientist at the level of Mendeleev, who was a physical, he was also Russian, was called Vladimir Vernadsky. He's a father of biogeochemistry globally. In 26, he published a book, Biosphere. The Americans, the Westerners got hold of this book only in the 80s. Now they find what Vernadsky, when you go to Moscow, you have got a Vernadsky Institute of this, because a decorated, globally accepted, decorated Russian Soviet scientist. He in that book said one thing: things are changing. Man has come to be considering himself as the master of the universe. He started using all his machinery and his equipment. He's devastating the earth. So, a new force, the social sphere, has come to dominate the earth. Its activities are as good as that of a geological force. That means a devastating force like an earthquake or a tsunami or whatever maybe, or mountain building process. So he called it Anthropocene. Anthropo meant humans. Anthropocene. CENE is a scene, that is epoch in geology. So he said that one. Then how to go about was his question. He said he classified the whole thing into geosphere. Geosphere means lithosphere, hydrosphere, and troposphere. And the biosphere, which is a evolution milieu of the whole earth. Then the noosphere, N-O-O-S-P-H-E-R. By noosphere, what he meant was that it is a cognitive process of the human understanding how to interact or react. What he said was that he put an order, that is, geosphere is the supreme, next one is biosphere, the man's cognitive powers, that is a noosphere, that should be listening to the rest. That means you listen to the biosphere, and through biosphere you listen to the geosphere. But man, what is doing is the other way. We want to dominate the other way around. He predicted the doom, but he was lucky in 25 this was not understood. Had it been understood by Stalin, it would have been massacred, because Stalin always thought the supremacy of man. Man will decide, man can do that. But he was lucky as a scientist. He died in 50 only, but whatever may be then. What Malthus said, Malthus is the, Marxists don't accept the Malthus, and there was one time, but what he said about it was about the population growth, how to control it. He knew that it's going to be a tragedy. If population outgrows the food production, the population will die. So how to go about it? So he said, so preventive check. Preventive check is one thing, you check yourself. You control yourself. Don't create more children. That was his one thing. Otherwise, what he said was that what will follow is that the positive check. Positive check will be beyond you, nature will take care of you. You check yourself, or nature will take care of you. So this is probably as a concluding, I have to say, in Kerala's context, I thought we can have there is some time out the discussion that can come out like that. That is what I thought, because it was, basically I thought it as putting what happens on the various spheres of the earth, how the man has come to interact, and what are the deleterious things or harmful things the human kind is doing to this one, and how our next generation will be impacted. So that part of the Kerala specific, I think we can have some sort of interaction and get on to that. That's my feeling. So with this one, I mean, this is something like a panicky situation, land and forest laws that is happening. I didn't want to read it out again. Say, it is all the humans are doing what we are facing, beyond which there are certain things we also should know. Deserts, mining and construction usurps around 7 million hectares of land every year. Then, deserts and semi-deserts occupy 53.3 million square kilometers of land, or 1/3 of our surface. Because we should know the limitations under which we live. Encroachment of sand, that means desert sand, swallows 44 hectares of fertile land every minute. This is happening. In Delhi, those who are from Delhi will understand. That is how it is advancing into this one. Forests disappear at a rate of 20 hectares per minute. This is, taking clue of what is the tropical forest in Amazons, etc. And in Kerala also, Chatterjee, when you look between 2019 4 and say today, I think it must be same, no? Close to that. Because we had 44% of the land area as forest in Kerala in 1905, and now the forest department has got all the ministers, they convinced that all the forest ministers used to say 28, 29. Only one minister, when I, in an interview, I just crossed him, he said, we have got canopy. So that at least that was Thiruvanjur Radhakrishnan. He was at least, at least practical to tell me that was canopy we have. Canopy is our canopy, what is a rubber canopy or water or tea canopy, etc. Then tropical forest, 4/5 of the green cover under obliteration. Then where will you go? We have talked about what the forests provide us, what forest laws will give us, and what these things, all the interactions. This has been told. Thank you for patient hearing.
I think this is probably the best talk I've heard on this. It's been an extraordinary interest. I just want to make one point. For Kerala, it is almost suicidal to go on this way because we are so crowded. Where do we go from there?
There is a way, because really speaking, you wanted to talk to?
No, I want to ask you.
No, I said, I thought of how to conclude. I told you that Varnadsky is the topmost, the man who dealt on this one. And he also got an article, he had an article in 45 published. Now it is republished in America in this recent 80s or something. He tells one thing. Well, the people are helpless. Those who are at the realm of administration, politicians, but they somehow don't understand. Again, I'm quoting the same person in a different article he wrote in 45, but luckily that article was never come to the notice of Comrade Stalin. But he says, but I was getting back to Malthus because it is either you control yourself or you let the nature take care of you. In Kerala's case, people are, I understand, it is a governed state. Governed. There are states which are not governed. You see, in a governed state, certain things can be what you call the preventive one. It is not only the will and wish or desire of the people alone, the individual alone. The society at large can have certain things. If you do that with a good intention, with a good communication, and with a good purpose, and if you do it with a concurrence, I think Kerala can still manage. That is my feeling. If you permit, this is a Chatterjee's slide I have taken. You gave me this slide, okay? And you look at, it's a geographic division, the elevation differences are given. You look at this part. This part is what you call the lowland, 0 to say 10 meters. This is a water-prone, flood-prone, inundation-prone area of the state. Including that will go up to Kumaragam in the central part, Cochin and all the places, starting from Karanagapalli onwards. This is this part. This is prone to inundation in the event of sea level rise or flooding or anything. So this is an area, for example, you have to have a habitat to take care of the flooding or inundation scenario, and habitat has to be, and infrastructure has to be built in that manner if you want. So here I make another mention. You have seen when we look at after the Kerala floods, and when United Nations declare it is a disaster of the century, I mean, two pictures come out as Kerala. One thing is the inundated Nedumpasheri airport, because that is one thing. The planes were in water and 300 crores of loss, and it was shut down everything. Had they been able to get on to 100-year meteorological data when they constructed it, it would have never been inundated, it would have been literally elevated. That is one option. Second option, to the west of that there is a canal coming and dead end. There is a dead end. Even today, if they extend that canal beyond the NH, National Highway, they have to invest money. Say for example, we, including me, if there is an opportunity, I will decry on America because their policies or whatever, maybe racialist, everything. But when you look at what they do for themselves, you admire them. See, in America, an airport is constructed based on 100 years. They have got a standard stipulation.
What did we do in Nandabal?
Pardon?
What did we do in Nandabal?
Say, for example, they have got meteorological data and they have got the intensity, every piece of information they put on this one. In Nedumpasheri, we do have 175 years of data, you know that. And if they bother to look at up to, say, if not 150, 60, 65, 70, they could have picked up the 1924 flood. 1924, 61 there was a flood. 61, it was substantial. And then 72, there was substantial. And if they had looked into those things, they would have seen that the water level should be up, first thing. Second thing, then again they will be missing. Those days there was no construction hindering the water flow. Now there is a highway and everything, that also should have been factored. And if they did it, the airport would have been at an elevation and unaffected by the flood. Here also this time I think 1 or 2 meters, 2.5 meters. And now they have got an alternative. They want that canal that is choked over there. If they can carry forward and reach there, it may take them 50, 60 or 70 crores of rupees. Still they can solve. But I said, what I wanted to emphasize is that we can get out of the situation if there is a will, if there are policies, if you are able to convince naturally some. Not only adaptation. Adaptation is one thing. You permit people, now you adapt. It's a water, you adapt. Either you live to as an amphibian or get lost. That is adaptation.